For our first lesson about prime factorizations, we will learn through a story called Prime Gems. In the town of Primatria, there is a special carnival-like park called Gymnasium, where instead of using coins, each game requires prime gems. To enter Gymnasium, each person must prove their ability to open their bag of prime gems. There's a special method. Upon approaching each entrance of the park, each child is given a bag of 10 prime gems pulled closed with a knotted string and a composite number written on the side of it. What's a composite number? It's a number that's positive that can only be divided by 1 and at least one other number besides itself. So some examples are 4, 6, 8, 9, 10. When you think of 4, you know it can be divided by 2, so that's a number that's other than itself and 1. 4 is itself and 1 is 1. It can also be divided by 2. 6 can also be divided by 2 and 3 besides 6 and 1. Same for 9, it can be divided by 3 besides 1 and 9. If the child is able to figure out all the prime numbers that make up the composite number, then they are able to untie the knots, access the prime gems, and enter the park gymnasium. Well, what are prime numbers? A prime number is a number that can only be divided by 1 in itself. So that can be 2, 3, 5, 7, and so on. The special method each student must use is called prime factorization. Emo teaches all the kids in Primatria about the method of prime factorization. She can help you too, so you can enter Gymnasium. But she won't give you all the answers. Emo says, prime factorization helps you find all the prime numbers. It's simple, just divide. Keep in mind that prime numbers are numbers that only can be divided by 1 in itself. The numbers that make up composite numbers, and some examples are 2, 3, 5, 7, 11, and so on. So we want to look for these types of numbers when doing prime factorization. Here's the official definition for prime factorization. It's using division to find all the prime numbers that create the original composite number. We want to start by dividing the number on the bag by an easy small number. If the number is even, start by dividing it by 2. If the number is odd, start by dividing it by 3. After you divide, look at all the resulting numbers and see which ones are prime. If there are numbers left that are not prime, then keep dividing until all the numbers are prime. Emo says, this bag has 4 on it. Since 4 is even, let's divide it by a smaller even number. 4 divided by 2, which is a smaller even number, is 2. And 2 times 2 is 4. We want to divide or factor until we have all prime numbers. The number 2 is on our prime list, right here. So we're done. We're able to untie the bag and enter Gymnasium. This bag has 6 on it, and 6 is even. Let's divide 6 by another smaller even number, 2. 6 divided by 2 is 3, and 2 times 3 is 6. Well, the numbers 2 and 3 are prime. We can find them on our prime list. So that means that we can untie the bag because we're done. We have found all the primes that make up 6. 9 is odd. So let's try to divide 9 by a smaller odd number, 3. 9 divided by 3 is 3. And 3 times 3 is 9. Both 3 and 3 are the same number. They're both factors of 9, and they're also prime. We can find them on our prime list here. So that means that we're done because we're able to untie the bag. 15 is also odd. Let's divide that by 3. 15 divided by 3 is 5, and 3 times 5 is 15. 3 and 5 are on the prime list, so we're able to untie the bag and enter gymnasium. This bag has 18 on it. 18 is even, so let's divide it by a smaller even number, 2. 18 divided by 2 is 9. So you can say 2 times 9 is 18. And 2 and 9, are they prime? Well, 2 is prime. We see that on the prime list. However, 9 is not on the prime list. 9 is on the composite list. That means we have to divide 9 again by another number. 9 is odd, so let's divide it by another smaller odd number, 3. 9 divided by 3 is 3. So we can write this again as 3 times 3, which is 9. Bring out our other 2. And we have all primes. 2, 3, and 3 are all on the prime list. And 2, 3, and 3 are all factors of 18. Let's try another one like that. 20. 20 is even, so we can divide 20 by 2. 20 divided by 2 is 10. We got 2 times 10, and that is 20. However, 10 is not on our prime list. It's on our composite list. So we have to divide 10 again by another smaller even number, 2. We can choose. 10 divided by 2 is 5. So we draw 2 more strings. 2 times 5. Bring this same 2 out because that's still a factor. And now we have all primes. 2 and 5 are both on our prime list. And 2, 2, 5 are all factors of 20. When we multiply them all together, we get 20. Why don't you try some for yourself by clicking next?